Hi, my name is Dimitri van Landuyt and I will present to you our short paper entitled Threat Modeling at Runtime, the case for reflective and adaptive threat management. Threat modeling is an analysis activity that takes place in the early stages of the development lifecycle and is widely recognized as an important cornerstone of the secure development lifecycle. So in accordance to the principle of security or privacy by design, you have to make sure that these concerns are not an afterthought during the development of a system. So typically, threat modeling is represented as a four-phased approach where it starts from the creation of a model of the system that is then used as the basis for threat elicitation, leading to a number of documented threat scenarios. So in the third step, these threat scenarios are then ranked in accordance to the risk that is calculated at the basis of certain risk models, and then a priority can be attributed to each individual threat scenario. In the final step, systematic mitigation is performed, for example, by selecting architectural patterns for security or tactics, privacy-enhancing technologies, building them into the system. And so in this sense, threat modeling and threat analysis also contributes to the privacy and security architecture of a system. Threat modeling is predominantly a manual exercise which relies extensively on human expertise, so the expertise of the analyst that performs the threat modeling exercise. In addition, it leads to the problem of threat explosion, which is a combinatorial explosion of potential threats to consider and to mitigate, and therefore it can be quite time-consuming and costly. For this reason, researchers have looked at ways to automate some of the activities in threat modeling with advanced tool support. These automation efforts have mainly focused on the two intermediate steps, so the generation of potential threat scenarios at the basis of the system model, as well as the automated calculation of risk and ranking of threats in accordance to these risks. And so on this slide, I've highlighted a number of related work items that indeed contribute to the automation of threat modeling. So in this paper, we present our research vision towards further automation of threat modeling, taking it away from the by design context in the early stages of the development and allowing threat analysis and threat modeling to occur in conjunction at runtime with the system. And so a first pillar, an essential part here is the establishment of these system models that are used as the basis for threat elicitation and threat analysis. And so in the first step of our vision, we talk about reflective threat modeling, using methods of reflection to indeed create these models for threat elicitation. And then in the final step, we look at adaptive security and adaptive privacy mechanisms, automated runtime reconfigurations of systems in support of hardening the system vis-a-vis a security or privacy perspective, and we call that adaptive threat management. So if we zoom in into the first pillar of what we present, the notion of reflective threat modeling, so the idea is here that we allow the system itself to create a suitable reflection model. So we envision employing reflection mechanisms and inspection mechanisms to inspect the state of the running system, and from those information sources to create abstraction models suitable for threat elicitation. So for this purpose, we require advanced transformations between the type of abstractions that you get from inspection and reflection towards these types of models that can then serve as a basis for threat elicitation. And so as we dig into this part of the vision, we see a number of key challenges emerging. In our paper, we shortly discuss the main challenges to accomplish this vision of reflective threat modeling. And so the first one has to do with the expressiveness of the model that you use as a basis for this type of analysis. So traditionally, people have been using models such as data flow diagrams, but it has been shown that they lack expressivity. There are certain aspects that cannot be expressed well enough. And so in our paper, we put forward the idea of using more expressive architecture description languages that describe the same system, but from a number of complementary viewpoints or perspectives, at least making distinction between design structure in the module viewpoint, next to the component and connector viewpoint, where you look more at the runtime structure of a system, and also the deployment and the deployment topology of the system, which are all useful perspectives to reason about security and privacy threats. In addition to that, when we envision using inspection and reflection platforms and mechanisms, we will see that there is heterogeneity in the nature of the information that comes in, and that heterogeneity has to be dealt with. So systems are increasingly built upon expressive platforms, and each platform comes with its own formalism in terms of what abstractions are used, and so conversion of these abstractions obtained through reflection and inspection towards the target model is going to be a challenge here. Finally, we know that any approach that involves extensive inspection and reflection incurs a certain cost, has a certain impact on the operational system, not in the least on performance, and so also taking into account this consideration, if we are going to operationalize the idea that we are going to keep in parallel to the runtime of the system this type of abstraction model synchronized, we also must make sure that this approach does not hamper or hinder the normal operation of the system. So in the second part of the research vision that we put forward in our paper, we focus on adaptive threat management. So we step away from the traditional architectural tactics and patterns and mitigations that you bake into the design of the system, and we shift the focus towards platforms as systems that are capable of runtime reconfiguration and runtime adaptation in response to certain security or privacy concerns. And so here we particularly focus on a set of technologies entitled adaptive security and privacy. So for example, adaptive cryptography, where you decide to change the way you perform cryptography to harden it at runtime, or adaptive access control, adaptive intrusion detection. These types of approaches can all change their posture at runtime, and the idea is here that we inform those reconfiguration activities from the perspective of the end-to-end threat analysis that is performed in parallel to the system. And so to enact the vision that is represented by adaptive threat management, a fundamental shift is required from the traditional design time mitigations and the countermeasures that you built into the structure of the system to the more upfront support of runtime reconfigurations of security mechanisms or of the system as a whole will be required. And this represents a fundamental shift in security by design. In addition to that, we envision the system to be able to reactively mitigate certain threats. So when we see certain events occurring that are representative of, for example, an attack, the system can react and automatically reconfigure, but also the proactive threat mitigation. So by continuously monitoring which threats occur in the system and how this evolution happens over time, we can also identify the needs to mitigate threats before they occur, and this is also interesting from this perspective. So we see particular value in the notion of risk events. So from this modeling and analysis perspective, you could determine upfront certain events that if they occur, a reaction must happen, and the instantiation and creation of such rules can be performed from the perspective of this model. Lastly but not least, the fact that we will have then a reactive mechanism, a planning mechanism through which the security will autonomously change its posture vis-à-vis the security and privacy threats itself becomes a valuable asset and must be appropriately hardened against attackers, because this is indeed how you could also bypass security mechanisms if you get control over this type of mechanisms. And so in conclusion, in this paper we presented an extension of threat modeling which goes beyond the current automation efforts in threat modeling. On the one hand side, we have presented our vision on reflective threat modeling, which involves the automated derivation of the analysis of the system models used for analysis. And on the other hand, we focus on adaptive threat management, where we are going to support reactive and proactive mitigations through runtime reconfiguration from a holistic perspective. So this concludes our talk on threat modeling.